Hi, this video is from section 5.1. It is to teach you about intercept or factored form for quadratic equations. This intercept or factored form is listed below. Y equals A times the quantity of x minus R1 times the quantity of x minus R2. As usual, A is our stretch or dilation factor, and R1 and R2 are actually x-intercepts of your parabola. This one I think is super visually helpful. If I just threw any old parabola up, when you're in factored form, you have the x-intercepts right there. It tells you where your parabola crosses the x-axis, and the stretch tells you whether your parabola is facing up, that's when your A is positive, or your parabola is facing down when your A is negative. So I think intercept or factored form is super helpful, and the name gives you a big clue. It's called intercept form because it gives you the x-intercepts. So going back to this graph that we've looked at a lot, we are in quadratic equations here in 5.1. We're finally looking at intercept form and how to graph parabolas from intercept form. So you know the graph of a quadratic is a parabola. You know the parent function is y equals x squared. We're going to look at this right here and start to recognize that as a quadratic. It's hard to see because, or to notice that it's a quadratic because you don't have the x squared there. But if you did FOIL this out, you would see you have y equals x squared plus 8x plus 15. So by foiling it quickly, you've moved it into standard form, and then it's much easier to see that it is a quadratic function because the x squared is there. So now looking at both of these, I can see my x-intercepts. They are here and here. I can see my A value of +1. I can see my y-intercept of 15. I've got really a lot of information already about this parabola. So let's go through and answer the questions. Number one, it talks about the intercepts. And if you noticed from the previous slide, it was x minus R1 or x minus R2. So I think of that as the opposite of. So since we have a +5, I don't like that color there. Since we have a +5 in our first parenthesis, our intercept will be the opposite of 5. So we'll have a point at -5, comma 0. And then we've got a +3. So opposite of it will be a -3, comma 0. So I look, my parabola is going to be kind of skinny. And I think then it helps me a lot to figure out my axis of symmetry. If I was going to fold my paper and make a horizontal reflection, it would have to happen right here because that's what would make those 2 points line up. So it looks like my axis of symmetry is at x equals -4 because this point was 1 away, this point was 1 away. It's like you're finding that average distance between your two x-intercepts. I know that this guy is going to open up because my A value is a +1. So that makes my pattern of change a 1, a 3, and a 5. Since my parabola is going to open up, I know my vertex is going to give me a minimum value. But now here's the challenge, is to find that actual vertex and think about how you might want to do something like that. This is where things get a little bit tricky. You have you have quite a few options of how you want to do this. And I think the first thing that will help me in my vertex is that I remember my axis of symmetry. That number actually gives me the x value of my vertex. My vertex always sits somewhere on that axis of symmetry. So I know the x value is -4. And now I think I'll just plug it back into my equation to find the y value of my vertex. So I have a 1 times a -1. So I have a y value at -1. So my vertex is -4, -1. And I actually think that fits in pretty perfect with my pattern of change because from the vertex, I go up 1 to the right 1, up 1 to the left, and then I hit those spots. From there, I'd go up 3 over 1, And from there, I'd go up 5 over 1. So I can create that nice curved shape to get my parabola. Make sure you don't have these parabolas kind of go inward on themselves. It would look just like that. Here's a second example. If you need to pause to copy this down and try to make sense of it, I encourage you to do so. Here's the example right here. We are in factored form. So my intercepts, I had a -2, so that became 2, 0, and a -4, which became 4, 0. So you can see at 2, 0, and 4, 0, I made my x-intercepts on my graph. My axis of symmetry is going to come in and cut those 2 points in half. Find the average of them, that vertical line, so it's x equals 3. Average of the intercepts, yep, just like I said. And then you go through and you see the vertex, the x value will be 1. I plug in 3 into the equation down here to simplify, so I get the y vertex, the y value of my vertex to be 1. So on my graph, 3, 1. Since my a value is negative, my a value is -1, I plug that in, 1a, 3a, and 5a. So it looks like I had to go down 1 over 1, down 3 over 1, and down 5 over 1 to get my parabola made. Thanks so much.